Can you hear me now? Thank you, Bill. So you've probably seen some of the previous presentations. You know, they colloquially mention RDMA Core and they say, wait till later. This is later. So I'm going to introduce RDMA Core. It's a bit old now, but we will give you all an update where we're at, what we've done, why we're here, and what everyone should be thinking about doing. So what we've done is essentially taken 18 different source packages, Git trees, tarballs, and other things, and combined them into a single unified source repository that we've decided to call RDMA Core. The maintenance team is the same team that maintains the kernel side, so it's Doug and Leon over there. Hello, guys. And it's designed to more or less be done kind of in lockstep with the kernel. So if we accept a kernel feature, then we anticipate that the user space component of that kernel feature will find its way into RDMA Core and then get delivered to the user space. It's live right now. We're on our second release. You can see it on the GitHub URL at the bottom. I think hopefully that's a clickable link if you've downloaded the PDF. And our scope early on, we decided to limit it mainly to the user space component of things that are part of Linux kernel's drivers and InfiniBand area. So this is really focused the project on this particular problem, and we're not trying to include MPIs or libfabric or other things. We're just, if you're talking directly to the kernel, you probably belong here. If you're submitting patches for kernel to Doug there, you probably belong in RDMA Core for user space. So these should all be familiar to everyone here. These are the basic core libraries that you see if you're using verbs and RDMA CM and so forth. A few interesting things is we've got SRP daemon and IWPMD included in this package. SRP daemon is part of the user space for the SRP module in the kernel. It helps locate SRP targets and set them up in the kernel and do a bunch of other stuff. And IWPMD is a necessary subcomponent if you're using any of the iWarp drivers. It does something to do with port reservation and iWarp. A quasi-new thing, a bit different here, is RDMA NDD, which Ira wrote. It kind of migrated over from InfiniBand diags. It hooks into much of the same kernel infrastructure, and it's more or less the user space component of the kernel, which tries to keep the host name synchronized in the node description. So it fit the same criteria. We also have all of the verbs providers. So if you're a verbs provider, you have to be in this list. And this list is exhaustive right now of the kernel, except for the still pending Broadcom driver, but it's going to come probably the next time they submit a patch series. One of the exciting things we've done this year is we've accepted a whole bunch of new providers into both the kernel and into the user space. So the ones marked in the kind of orange color, I guess it's yellow on that screen, are the new providers. So we have the Huawei provider, the QLogic Cavium provider. You've heard from the people working on RxE and VMware's provider earlier already in the sessions. So everybody should be familiar with those is. So those have all gone into RDMA Core. And part of what we're doing for the people working on providers is we've kind of taken responsibility now, the RDMA Core team, to get their providers into the user's hands through the distributions. Right? So that's part of the value add that we're working on is we want to see everybody in distributions. If I get Debian or I get Red Hat or Ubuntu, the full and complete RDMA stack should be present for user space. Right? So we talked about it on the list again, and we eliminated some things that were not going to be included. I've sort of touched on them here. The middleware libraries were pretty quickly wiped out. It didn't really make sense. We deleted a bunch of drivers in Linux 4.8, so they're gone too. They didn't get carried forward. If you want to use obsolete hardware that's 15 years old at this point, you need to do it yourself. We didn't take any of the management layer stuff. There's an awful lot of management layer stuff, so we just sort of drew an arbitrary line. It's kind of weird that InfiniBand diags and libIBMAT are sort of still floating out there on their own, but I think Ira might have some plans to do something with that. And this next one here, this requirement for upstream is something that a lot of us really believe in a lot. It's necessary really to have credibility in the Linux community, and we are very strongly upstream first, right? If you want to get a change into RDMA Core that touches a kernel feature, you need to get your kernel feature accepted first. We're not going to be enabling or supporting people to do proprietary or out-of-tree kernel stuff. That you're on your own if you want to do that. So it's not terribly big. It's still pretty accessible. It's much smaller than the kernel. That's good. And I was inspired to add this particular slide after seeing some of the earlier presentations here. So how does this actually work? You know, hopefully people are kind of familiar with the waterfall process that we kind of see in the open source. We have the tier called upstream, which is where Doug and Leon and myself tend to work. These are the upstream Git repositories. This is Linus's kernel tree. This is the GitHub for RDMA Core. You get your code into there. Then those teams, and they're quite big teams in the case of the kernel, work to get the code into what are now called the rolling release distribution. So we've got like Fedora Core as an example, or Debian Unstable, and I've sort of placed OFED in this tier 2 where it's taking upstream code and it's getting it out to users kind of quickly. The idea is to get it into users' hands quickly so that they can test it. We can get more feedback. People can explore new features very, very easily. And then we move down into, maybe we've done more testing. Maybe it's an Ubuntu named official release, or it's been QA'd by one of the vendors, and now it's a proprietary OFED. And then the further level of even more testing is we've reached the long-term stable releases from the main distributions. So these are the Red Hat Enterprise Linuxes, the Ubuntu LTS named releases, or some of the SUSE releases, and so forth that you're all very familiar with. So there's a long road to get code from it's in upstream, and it's got to get down into the bottom here on one of the LTSs. And that is sort of what the team involved with RDMA Core is helping to shepherd, to work with these distribution people and make sure that everybody's happy, the code builds in all these scenarios, and all that boring little work happens. The interesting thing, I think, in all of this is that we don't actually call RDMA Core, or the stuff inside the kernel, we don't actually call it OFED. Right? It's not called OFED. OFED is something else. The upstream work is we just call it upstream. I would encourage everyone to kind of adopt that. If you want to get, these days, if you want to get the latest RDMA system, you can actually get it from someplace like Fedora Core or Debian Unstable. Fedora Core is a little bit ahead of the curve right now because they've already got the packages. But if you get Fedora Core 26, you will get newer software than is in OFED. So if your goal is to experiment with that, that's a really easy way. It's had a decent amount of QA done on it. And I would encourage people to look at that. So the main purpose of all of this, is I've sort of already touched on, is to take some of the responsibility out of the hands of individual people who may be working on one provider or something, and try and share it. So we have 18 providers. Not everyone needs to go and try and communicate with Fedora and get them to accept a package or something. No, we don't need to do that. Red Hat and Gerard are handling that for everyone now, and it just goes much easier, much faster, hopefully. We've also been focusing on integrating the providers and kind of bringing them to a more of a common coding standard, and getting the source tree to a level where the distributions are going to be happy to include it, where things like it actually compiles, for instance, on a modern Linux distro. That's a bonus, and it is able to pass compilation without any crazy warning messages. It doesn't have linter errors. It passes coverity. All those little things that in today's security-conscious world we want to see in our code bases. So this has been going on since August. We've done 2 releases. We're calling them release 12 and 13. The number doesn't really mean anything. The number will just keep increasing. There's a lot of commits, a lot of lines changed. Some of those are those new providers adopted. We've successfully got it into Fedora Core. So Fedora Core 26 will include RDMA Core. It was used as the basis in OFED 4.8 for all of the user space components. So that's transitioned over. And there is packaging and progress, but it's not landed yet for Debian Unstable, and that's the path to get into Ubuntu. So that's ongoing. It's difficult. Not a lot has changed. If you're an end user of the libraries, you're using the APIs. Not too much has changed. Some of the presentations that have come on this conference are going to talk about the individual micro changes. We have something called verbs direct now, timestamping, packet pacing, that kind of thing. All of the new providers are probably the biggest user visible change. If you're using this hardware, you're going to be getting your software stack from RDMA Core. If you're using RxE, you're going to be using RDMA Core as well. And it's not user visible, but it's worth pointing out that we've now stopped supporting provider libraries that are out of tree. So if you want to write hardware, you need to get your code in upstream Linux, and you need to get your code in upstream RDMA Core, and we're not going to support any other options. It's too much work for us. Nobody was taking advantage of that ability. It's gone. It's gone now. The work that's been done in those 800 or 500 commits is a lot of it has been just cleaning it up. The code, a lot of these codes haven't been touched in years. It started off in about 2005, and we had stuff of that era still floating around in terms of how you approach building software, what kind of GCC options you expect to use, and so forth. And that's been all cleaned up now. We've gone back to the distros and we've had them do their evaluations, run their linting tools, and we've cleaned up all of that stuff. We've gone to the distributions, we've pulled in all of the patches that they've been carrying that for some reason they didn't get upstream or weren't able to get upstream, or there was no one to take them upstream. So it's all been sorted out. We did the copyright audit, which may have caused Susan some of the pain that you heard about yesterday. The answer is we have copyright. And there's many different copyrights inside of RDMA Core. It's not a pure dual license. There's lots of variations, small variations. At a very high level, we can say that it's definitely compatible with the GPL, and it's definitely compatible with BSD code, and it's definitely okay for distributions to distribute it at this point. So, that's as far as we've gone. If other people want other things, they're going to have to look at it themselves. We've also spent a lot of time being forward-looking. So to be in Fedora Core 26 means you're going to have to compile with GCC 7 probably, or new versions of CLang, support different processors and architectures, and all of that has to be cleaned up kind of globally across all of our providers. And we don't want to see GCC saying, oh my goodness, this code is scary. It might be a security hole in its new warning stuff. So all of that has also been fixed. And we've provided more tools for the providers to use so that not everyone is implementing their own list.h and so forth, and a single configure struct that everyone uses that works the same way. So there's a lot of value coming into the people working on providers and so forth. I think probably many of you are familiar with GitHub, but I thought I'd encourage people to, if you have any doubt how to use this, I've got a couple slides here, so you yourself can go back home and you can try out RDMA Core. You can try it on your own computer. Maybe you can make a patch. It'll be great. So this is what GitHub looks like if you go to the home page, as it were. We only use GitHub for distributing the source code via Git. The main discussions happen on the mailing list. The usual RDMA mailing list for the kernel also doubles as the one for RDMA Core. So if you have a patch, or you have a question, or an RFC, or whatever, we recommend sending it to the mailing list. If you just have a little simple fix, like, oh, I found a typo in a man page, or I think this man page needs a little note or something, send a pull request directly to RDMA Core. So if you do want to actually use it, these are the basic steps. This will get you started. You clone it, you build it with the little build script. This presupposes that you've read the README and installed all the dependencies. But once it's built, one of the new features we've been able to add is that you can run it. This is something you couldn't do before. It was not runnable without installing it. But now you can run it. You've built it, you can run it. You can run other apps using the libraries. It automatically uses the right providers. Everything works really easily without having to install it. So this makes it much easier for just anyone to try it out. You can compile it. It's on its own directory. You don't need root. You can do your testing. You can evaluate it. You can do whatever you want to do. And I've got a couple of queries on the mailing list and things. I'm just going to say for all of you, we don't recommend using make install with this. It's difficult. It's supported, but it's difficult. You have to set up a bunch of paths because distributions are different. From that point, if you did want to install it, say on your cluster or test cluster or something, we have some tools that will help you build it. These are based on Docker, but it's the tools that I use to make sure that the upstream is able to be packaged and delivered into all these different distributions. So you can build packages for CentOS 7, for instance, or 6, or Fedora Core 26, or the array of SUSEs and Ubuntus that are out there. if you want packages, something that you can install, this is a really, really easy way to get there. You can also use RPM build and so forth. And of course, we support pull requests. So if you want to make a change, you can send a pull request. Here's an example from Hal that's doing something good. Change our man page to fix something up. So you send the pull request. It's very much like on GitHub. You fork it, you push it, you pull it. Pull request works. If it all goes well, most pull requests are merged these days within about a week. It's pretty fast, fast process. To make things better for everyone, we've got Travis working. So this is again part of the common infrastructure that we are providing to all the participants, like all the providers and so forth working on the project. We have a central Travis. Travis is a continuous integration service, and basically whenever you make a pull request on Git, Travis goes out and runs some jobs on Amazon or Google and compiles it for you. And our Travis scripts are designed to check for code quality things, like does it compile without warnings on a very new GCC? Does it pass sparse checks? Does it compile on 32-bit? Would it compile on ARM? All these kinds of questions, our Travis run will answer. So the upstream should be, the current Git head should be in pretty good quality, is kind of the hope there. And if you do run Travis, you get to see the results. Travis is kind of neat. If you've never used it, you get a list of a log file. You can even watch it run in real time. It's very cool. If you're interested and you just want to watch what's going on, you can go on GitHub and you can subscribe and you can get notified of when people submit pull requests or when pull requests are accepted or patches are pushed or so forth. You get, you can keep up to date. You can also subscribe to the mailing list. There's a little bit more volume there, but if you care about this stuff, if you're using it or these things are important to you, I would very much encourage you to subscribe to the GitHub, subscribe to the mailing list, keep an eye out. Raise your voice if you have something to say or something seems, interesting to you, or wrong. If it's wrong, definitely speak up. So the next set of my slides is some discussions on stuff that needs doing. These could probably be tackled by a lot of different people. Depends if you have an interest in it. If it intersects, if this is a pain point for you, go ahead, take it on. We have been lucky that Doug has provided us with basically the whole Red Hat packaging. So this includes not only the RPM stuff, but all their boot scripts and enablement to make the system boot correctly so that your devices start up, the UDEV rules so that the kernel modules load. And one of the goals here is to make that more broad and to have the other distributions have at least a similar capability, if not the same scripts. So you may have noticed if you're using Ubuntu compared to Red Hat, there's a lot less of that in Ubuntu. Ubuntu doesn't automatically load the modules. It doesn't set stuff up the way it does in Red Hat. So we'd like that to be moved across. And the same goes for systemd. Right? We kind of expect that the systemd unit files are the same on all the distros. And details like IBA-CMD should have socket activation. SRP daemon should just work. It shouldn't require kind of the weird configuration that it does. More systemd stuff here where for some reason we depend on the subnet manager being started on the node if it's going to be started because of stuff. And if you want to see what it's supposed to look like, RDMA NDD turned out there. It's systemd integrated. It's integrated with UDEV. It just works, right? If you hot plug or unplug or do whatever, it just works correctly. The idea is that we want systems to boot up properly and not be flaky. And I boot 1,000 nodes and 3 of them didn't boot successfully because race conditions and all that kind of crap. And the kernel module loading is kind of the same thing. Somebody could really tackle this to fix up some of the boot problems, the hot plug problems that we have. This is, unlike other kernel subsystems, if I plug a card into my system, an RDMA card, I probably don't get the right kernel support. I have to go manually load all these modules. I might even have to manually load other drivers before it works. And this has been solved in Red Hat with a bunch of scripts, but arguably it should be solved in the Linux kernel. So it's just, again, a robustness thing. We'd like it all to work. We've mainly, so far, at least within the core team, only been talking to SUSE a little bit, Red Hat, and Debian. The other distributions I haven't had any contact with them. They haven't come up on the mailing list. I'm not even sure that they know this change has occurred. But the InfiniBand stack is present in these places, and if anybody has an interest in these distributions, feel free to stand up for our community and say, can you take this on? Can you get the new stuff packaged? You got to be aware of this. It would also be really cool, this has been talked about, a great little job for someone would be to get the OpenSUSE build service running on our little source tree here, so that you'd be able to do automated compiles on different architectures like S390. I think we currently have a problem where it doesn't build correctly on S390, and nobody has access to an S390, so we can't fix it. But that makes it easier to get things into the distros. One of the ongoing projects that we've been working on for a while now in the kernel is this concept that we're going to try and actually enumerate and describe what our UAPI is. The kernel has this convention of include UAPI. So you describe a UAPI, you put it in a header file, and you stick it in that directory, and now it's official. And we've been trying to move all of our UAPIs into this format and get everything cleaned up so that it's sane and usable, and the rest of the kernel community doesn't say, you guys are nuts as much. But part of the trouble is that's fine, but we want to actually use those headers now. It's the same thing to do. So inside verbs or inside of other RDMA core things, we'd like to use the kernel headers as they exist in the kernel, and it's very difficult. There's lots of problems. Verbs is the biggest challenge, where their kernel headers have been copied into the source tree and then modified because we can. Long ago, this was the thing to do, so they're actually different, and some sort of resolution is needed to make them actually work together. This is going to become kind of differently important as Matan's work to get the new UAPI cleaned up and upstreamed goes through. Then we're going to have a right mess. It's going to be great. The providers, so the interesting thing about RDMA, particularly verbs, is we have these user space drivers. And the drivers in user space are doing things like DMA, they're doing IO port accesses, and we've never had like a library that provides the common primitives to even do that. So every driver open-coded them, and half of them are wrong, and half of them are just weird. So one of the big projects would be to implement a shared read-write, relax kind of thing, like the kernel has, that all of our providers could use when they're talking to I/O memory. Then we can have things like the correct ordering and the correct byte order, and maybe it works on S390 because they're different and weird too. But that's a big job. We're still working on that little piece by piece. We need to get sparse working, I think, before we tackle that. But again, the goal is to help out the distributions and help out people like our friend from the ARM world here who came up and said, I want this to work on ARM. Yeah, it almost works on ARM. There's probably a lot of little bugs because I don't think in user space we fully appreciate the relaxed ordering model. Certainly not when doing IO accesses. We do not have enough stuff like the kernel has to make ARM have a strong ordering model like many of the drivers expect. So there are undoubtedly little bugs inside of the world here if you're running on a relaxed system like ARM and it hasn't been well tested by the vendor, or it's one of our new drivers or something. One of the changes that kind of comes in all of this is that most of your distributions now are going to include all of the user space components. So if you're running on Red Hat, you're going to have drivers for RxE, MLX4, MTA. They're all going to be installed. And consequently, a little bit unfortunately, this means that all of your verbs users are going to load all of them. It kind of makes the plugin architecture kind of pointless. But this is something that could be optimized. Some work could be done here to be clever about when we load providers and which providers we load, and just to optimize memory footprint and startup time. Very, very small optimization. Something that some people have talked about, and I don't think a solution has come forward, is what if I'm a vendor and I want to upgrade the provider inside my distribution? I want to provide just a provider upgrade. That's always been kind of difficult. It's more difficult now, but perhaps there's some work that can be done. The call to action is, of course, that everybody should try to participate upstream. So if you are working on products that include the InfiniBand user space component, I would encourage you to at least monitor what's going on upstream so that you can be aware of changes that might impact you. We have made changes. All right, we're going to keep making changes to try and get some of the things that I've talked about before sorted out. If you're going to be doing testing, we encourage people to test upstream. Testing OFED is good. Testing upstream is better, right? The closer you can get to the top of that waterfall diagram I showed you, the shorter lifetime that bugs will have before they get fixed, the less chance there will be that bugs make their way all the way down to an enterprise distribution and start affecting large numbers of users. And the big sort of message here is that the previous source trees, the previous Git repositories, tarballs, those are all mothballed. There's going to be no new releases. There's going to be no new commits, no new work, unless somebody else decides that they want to do it. The core team here is not going to take that on. If you need new stuff, you're going to be told to use RDMA Core, or you have to solve their problems on your own. All right? I guess that's the end. Are there any questions? Oh my goodness, there are questions.
Yeah, well, So Susan and I were talking back here.
Yes, during my presentation, thank you.
Yeah, well, I mean, it wasn't that important, was it?
No,
And I've updated the maintainers page on OpenFabrics to point to your repo for the components that are appropriate. Have you talked to the previous maintainers about removing their Git trees, though, off of the Git page? Because we probably should do that as well.
So my experience communicating with what you call the previous maintainers is that many of them don't answer emails at this point. This is part of the reason why we did this, is because things have gotten kind of bad, particularly for some of the things that are a bit older now. Like, they're just not maintained. There's no one that's responsible for them, really. So my advice is that the Git pages that you're talking about are under the control of the OpenFabrics Alliance. I think the OFA should make one final effort to talk to those people and then get rid of them. That's my advice.
Okay, I'll send a mail to the list.
I'm not going to pursue that myself. Okay.
Well, just so people don't get the wrong code.
Exactly. It was. I didn't mention this during the slides, but one of the other motivating reasons was that it is very difficult to even find the correct code that you needed to have. There were like 4 different Git repositories for libRDMA CM out there, and they had different things in them. And it was difficult to say, oh, that's the right one. That's the one that I need to use today to get the latest. John.
Thank you, Jason. Is this on? Jason, we really appreciate your effort. This is good stuff, you and everybody involved. Just to let you know, it is in the OpenSUSE build service right now.
Okay.
It is currently being built into Tumbleweed on PowerPC, ARM, and S390. Of course, it is not necessarily successful on those architectures, as well as Intel. But effort has been put into making it work. On the Intel side, it is going through what we call the OpenQA, where it actually does a distro install test on the entire thing, although there are some testing procedures we'd like to add to the OpenQA process in order to validate what RDMA Core has. And so I suppose we'll get on the list and discuss these things and figure out what would work best.
Could you send a link to the list for the OBS results? Is that public?
Most definitely.
I wouldn't mind checking them out.
Sounds like something that would be a very good presentation for next workshop.
Yes, getting this stuff to run on every architecture out there is actually quite a challenge.
Well, and we've got the tools that should be able to help. So
yes.
I'll send you the links. I'll
All
get
right.
you the details.
Thank you, John. And for the audience, John represents SUSE, so he's the official voice of them. Woody.
Yeah, I have a question, or a clarifying question, I guess. So you were mentioning about the ability or non-ability to, like once the code is, say it's been picked up, it's now in a Red Hat or SUSE distribution, and I'm a vendor that owns one of those libraries, and oh geez, I find a bug, and of course I'll submit the bug to the upstream, but the process of getting through the upstream and in my customer's hands sometimes is long, and so the customer says, I want something tomorrow, and so a lot of people will, and they do this with drivers as well, right? They'll they'll give a newer updated driver to their customer to fix their bug. Did you say they will or is not a way to just individually upgrade like one single provider that's already been installed in a distro?
Right, it looks like the way that Red Hat and perhaps Tuesday has chosen to package this is that all providers are in a single package. So,
Okay.
you know, depending on your need, there's ways to get there. It just might look different. For instance, you could go and download the source RPM. You know, talking in a Red Hat world, you could download the source RPM directly from Red Hat for, you know, 7.4. You could put your patch into it and build it for your customer and give them the RPM set, and they can install it and they can get your fix. Right. And at the same time, you should be, of course, asking, you know, Red Hat to.
The concern on that is, is, you know, if I give my customer some package, okay, so here's the case in point. So vendor A has the problem. They download the package, they put their one bug fix in, they give it to the customer. Now, that customer also deals with vendor B, and vendor B had a problem. So they download the package and they overwrite the fix that this guy gave. So, you know, you might want to really consider looking into having a way that you could replace individual providers. We ran into the same thing with Live Fabric, and I know that, you know, Sean's been working to engineer a way to do that in the, you know, in the field. They just, you know, so
no,
suggestion.
I understand where you're coming from, but at the same time, like we need to kind of put our foot down in a certain way. Like if the vendors are not cooperating and they're not working with the distribution, then they're just making a mess for the users.
But even if they're working with the distributions, you know, there's sometimes a lag between, even if I wanted to get it, you know, through Red Hat to a customer, there can be a lag there.
Right. But I mean, you're assuming that the patches just affect a single provider and that it's all nice and safe, and that's not always true.
It's not always true, but in those cases, it's just like when there's a driver update, right? I have a driver bug, you know, I release, you know, an update driver that they can put in Red Hat in the updates directory or something like that, right?
So it's
and then Red Hat would pick it up, it would go through their process and their QA, and the next time they do an update, you know, it could get in there.
There's certainly a way that we can achieve it. I'm not sure anyone's working on it right now.
I'll address some of that. So speaking from the Red Hat perspective, right? Because some of what you're talking about is exactly what we do. And so when we incorporated the RDMA Core, we had the choice of either packaging all of the providers up into a single RPM or splitting them out. And without boring anybody with a lot of technical details about how miserable it is to try and create a, say, RHEL 7.4 install CD that has different package names than your RHEL 7.0 install CD, which is a thorough nightmare. Anything that was split out for as a previous package before is still split out as a previous package, even though it comes from one source code repository. So you download the RDMA Core source RPM, and when you compile it using our spec file that's part of that RPM, you will get all of the different RPM, binary RPMs that you used to see prior to RDMA Core. And that includes anything that was on the system prior to RDMA Core as an individual provider will be spit out as an individual provider. So if you truly had a patch that just touched a provider, you could download the source RPM, build it locally with the patch applied and just a slightly modified version number, put that slightly modified version number on the specific provider you need to fix, and then you could provide just that provider update.
Okay.
And so that would work. And there's a few special rules you have to follow about numbering in order to make sure that the next update, like for instance, when we do our next point release, you'd want our point release to go ahead and update, because presumably you're not going to do this without filing a bug with us to make sure it doesn't get missed in our next update, right? Yeah. And so then the only real problem that you run into is for the new providers that didn't exist before, we did package them up into one package, in which case you'd need to create a new package that had all of those, and then only your one would be modified to that. And again, you just follow the numbering scheme so that the updates happen properly, and that kind of stuff will happen. In the rare, uncommon, really crazy event that you've got two different vendors, each both needing to do this and needing to do it in the same package, you guys are just going to have to coordinate, you know.
Yes, you can talk to other vendors.
Right. So if you did yours first and you provided a minor bit number update on the package version, the other vendor would just have to get your patch, add their patch, and then increment the number once more.
Part of the problem there is you may not know necessarily. Right?
No, the customer's going to have to be the
would
one
have to
that
know.
does that. The customer's going to have to be proactive and say,
both
I've already got this, customer's gone to Intel and they've gone to Mellanox, and they've already got a patch from Mellanox. When they come to you and say, I've got a bug, but look, I'm already running a modified package, here's my patch I got from Mellanox, so if you send me a new package, it's got to have that too.
Okay.
That'll be on them.
Right. So Doug, just a quick question is, so is Fedora and Red Hat different in that packaging regard? Because I think I saw Fedora. Yeah, okay.
Okay.
One last question, I think, is all we have time for.
Yeah, hi. First of all, thanks a lot for the good work you're doing, and Doug and Leon also. So we've just entered the kernel in the RDMA core, and my question is about the two mailing lists, because we've been requested, and we're following that, to post to both mailing lists, but sometime
What's the
I'm
other-
into
what's
the, when I'm posting patches, I'm posting it to the RDMA, Linux RDMA mailing list and
yes.
to GitHub. Sometimes the discussions are ongoing in GitHub, they don't reflect in the kernel mailing list.
Yeah.
So
This is an ongoing pain point for Leon here, and I think we're still determining exactly what the workflow should be. But the general guidance that I've been giving that seems reasonable is if it's simple and trivial, just do it on GitHub. But
Yeah.
if it's big and it's important and it might have a complicated discussion, then definitely send it to the mailing list. For workflow reasons, I know that Doug prefers that things are submitted via pull requests versus trying to cherry pick them off the mailing list. So if you want your things to be picked up faster, send them a pull request and it'll go in faster. Otherwise, you have to wait for someone to pull them out of the mailing list.
Okay, sounds good.
Kind of the advice. I think we're seeing how this works. It's kind of new for a lot of us, and if it's not working, we might stop or might do something different or say it all has to be on GitHub, like Sean has done somewhat successfully, or it all has to be on the mailing list. But right now we're doing this weird use your discretion kind of thing. Sorry?
Put it all on the mailing list. The models I can point to is too easy to live for everything.
A lot of stuff is on the list, but yes. All right.
Thank you.